Hello everyone, my name is Nevi Parsana and today I'm going to talk about the isokinetic dynamometer. Here, the isokinetic dynamometer, which is highly advanced tool used in rehab, sports science, and clinical performance testing. So, this device is designed to measure strength very precisely by controlling the speed of the movement and giving real time resistance. So what makes this tool special is that it doesn't just tell us whether a muscle is strong or weak. It actually shows us how the muscle performs through the entire range of motion. That makes it extremely valuable for clinicians and athletes. So here, what makes this tool unique? The isokinetic dynamometer is unique because it keeps the movement speed constant no matter how hard the patient pushes or pulls. Unlike free weights, where momentum can help you cheat through the motion, here momentum is eliminated. So the resistance automatically changed based on the patient's effort. If the patient pushes harder, the machine matches that force instantly. And if they reduces effort, the resistance reduces too. So this means the data we get is clean, reliable, and objective, with something we can't get from manual muscle testing or free weights. Here's so here's so what's actually happening inside the machine. The key component is a servo-controlled motor. This motor is what maintains the constant speed. Next, the machine has load cells which measures things like torque, force, and power continuously during the movement. Finally, the software takes all these measurements and create different kinds of curves, such as torque angle curve, torque velocity curves, and fatigue curves. This provides a very detailed picture of muscle behavior, not just a single strength number. Here's how a typical isokinetic test works. First, the patient is positioned and stabilized so only the joint being tested is moving. For example, knee extension, as you can see in this picture. Patient is sitting stabilized and like a patient is in sitting position and stabilized, and this machine is just working on the knee extension. Then the clinician sets the angular velocity using something like 60 degrees per second for strength or 180 degree per second for power. The motor uh, the motor then prevents the patient from moving faster than speed. This keeps the test consistent for every single repetition. Finally, the machine records detailed data throughout the entire movement, giving us objective strength information across the full range of motion. The isokinetic dynamometer provides several important outcomes measures, such as peak torque. This is the highest torque the muscle produces during the movement. Um, angle of the Angle of the peak shows the exact joint angle where the muscle is strongest or weakest. The third is work per repetitions, measure of muscular endurance, helps assess muscular endurance. The fourth one is fatigue index. Fatigue index shows how torque drops across repeated repetitions, helpful for return to spot decisions. And the last one is agonist antagonist ratio, like quadriceps to hamstring ratios, which are important for injury prevention and post surgical rehabs. This tool is extremely valuable in rehabilitation. How it helps helps clinicians identify specific strength deficits, especially after orthopedic surgeries or injuries like ACL reconstruction, rotator cuff repair, or ankle sprains. Unlike manual testing, which can be subjective, the dynamometer provides data that is considered and reproducible. It allows it allows patient to save maximal effort safely, and because the machine is control the speed, whether the patient is forcing too much or too less. Accordingly, a machine changes their like resistance as well. And the last one is for return to sport testing. We often look 80 to 90, like we often look for 90% limb symmetry, which is something the dynamometer measures very precisely. One of the best thing about this tool is how visual the data is. The torque angle curve shows how strength changes throughout the movement. This helps identify at which angle the patient is weaker, something you can't see with a regular strength test. I'm sorry. The machine also gives concentric and eccentric curves, um, which helps evaluate muscle control. We also get bilateral comparison graphs that shows difference between the injured and non-injured limbs, extremely important for progress tracking. And finally, fatigue curves. Um, it shows endurance capacity across repetition. Here is the comparison with alternative tools. First is handheld dynamometer, which are portable but very less reliable with strong muscles. Second is free weights. Free weights are great for training, but don't measures strength objectively. Third one is force plates, are excellent for ground reaction, but don't isolate specific joints. So the isokinetic dynamometer is the gold standard because it provides the highest precision and reliability among all these tools. Here, this tool is used widely in clinical and sports setting. For example, SCL rehabilitation to evaluate quadriceps deficits. Second is shoulder rotator cuff assessments for overhead athletes. Third is ankle strength testing, especially inversion and eversion. Then return to duty testing for workers or tactical athletes, such as firefighters or military personnel. Because the data is objective, it helps clinicians justify the decisions and track real rehabilitation progress. Here, the first picture shows for the knee extension, and here the bottom one picture is shows for the rotator cuff and arms and wrist as well. And here the third picture is showed for the back extension. Now, of course, the isokinetic dynamometer is not perfect. Some clinicians rely too much on the numbers and ignore functional movement patterns. Another limitation is that it mostly tests single plane, isolated isolated movement, which are not always reflective of real life or sports movement. It's also expensive and takes time to set up and requires training to interpret the data correctly. So, understanding how to use it properly is essential. Here's the evidence-based strategies for effective use. It should be combined with other assessment tools. For example, pairing it with EMG can show muscle activation pattern. Then using it with gait analysis helps in lower limb injury. Combining it with force plate jump testing helps athletes return to performance safely. When the data from different tools is integrated together, clinicians can create highly individualized and progressive rehab programs. In conclusion, the isokinetic dynamometer is truly a gold standard tool for assessing muscle performance. Its precision, safety and ability to give detailed biomechanical data make it extremely valuable in rehab and sports settings. But its real strength is real strength lies in how clinicians use the data to make better decisions, which is the core behind technology, literally in practice. Thank you.